that was the end of the last lesson. Now we pick up at the next point in this one. And we start talking about what we call postulates or also axioms. Postulates and axioms are the same thing. And the thing about a postulate or an axiom is that we both accept that it's true. I just can't prove it's true. Okay? For example, if I said to you, a quarter is a quarter. I can't prove that, but we both know it's true. We accept that it's true. And likewise, one of the things that we accept is what we call the addition postulate. There are many postulates. There's one called the symmetric postulate, which says if A equals B, then B equals A. Or it could be if Joe weighs the same as Bob, then Bob weighs the same as Joe. Again, we can't prove this, but we accept this to be true. With the addition postulate, what we're basically saying is when equals are added to equals, you get equals. So when equals are added to equals, you get equals. In this case, if I say Mn plus No, what do I get? I get Mo. If I say MP plus PQ, what do I get? If I say MP plus PY, what do I get? If I say OR plus RQ, what do I get? And lastly, if I say MN plus NZ, what do I get? So going back to the first one, I said if I take the distance from M to N and add to it from N to O, if I take segment, because that's what it says on top, segment MN, and add segment NO, I get segment MO. And that's my correct answer. What do you think for the next one? Okay, if I add MP, which is right here, to PQ, which is right here, I get from M to Q, so my answer is MQ. Let's try the next one, MP plus PY. Okay. So if I go from M to P and then from P to Y, altogether I've gone from M to Y. In other words, I add them and I get MY. Try the last two. Little stop and start here. Segment OQ goes first because if I go from O to R and then R to Q, I've just gone from O to Q. And lastly, MN plus NZ will give me from M to Z. Okay? Now, we have an addition postulate, and then we also have a subtraction postulate, which when we get involved with it a little later on means when equals are subtracted from equals, you get equals. And likewise, I can also express that with line segments, just as I expressed addition with line segments. So here are 5 questions. And the first one says, if I have from M to Z, and I subtract from Z to O, or right here, then I'm left with from M to O. Okay, you try the next 2. Don't do all 4, just do the next 2. Go ahead. Okay, so if I go from MY and I take away PM, I'm left with YP, segment YP. And likewise, if I do segment MQ minus segment QY, I'm left with segment MY. Sorry, I almost said MP. MY. Let's try the last 2. Stop and start. Okay, if I do OQ and I subtract RQ, I'm left with OR or RO. And if I do from M to Z and I subtract from N to Z, I'm left with MN, segment MN. Now, how can we begin to see some examples of this within the Cartesian plane or the coordinate plane? Well, If the distance from A to B is 7 and the distance from B to C is 3, what's the total distance? Well, this isn't rocket science, all right? If it's 7 units from A to B and 3 units from B to C, if I just count them all, ready? 1, 2, 3, 4, 5, 6, 7. And the next one is 3, but I could have kept going on going, 8, 9, 10. AC would be 10. Now here's something real important to notice. Do you notice how I didn't put any hats, if you will, or segment ray line symbols on top? That means when I put no symbol on top, that means the distance. It means the distance from A to B. So if the distance from A to B is 7 and the distance from B to C is 3, what's the distance from A all the way through to C? It's 10. And one term that we might have to describe the alignment of these points all on the same line would be collinear, okay? Collinear. When all the points are on the same plane, like these also are, they are coplanar, and when they're on the same line specifically, they are collinear. So write a statement. Let's go back to the other one. The statement that I wrote here was if AB is 7 and BC is 3, find AC, which we said was 10. So you write a statement for this guy. Go ahead. Little stop and start. So if AB is 10 and BC is 4, find AC. AC is 14. Now remember, the big reveal here is when I don't put any notation on top here, and I'm not saying, hey, A to B as the line segment or A to B as the line or the ray, then we know no symbol on top means we're talking about the distance, okay? Now, as far as an explanation of this goes, if A to B is 10 and B to C is 4, then the whole distance is 14. Now, let's turn it into a new question. If from A to C is 14 and B to C is 4, what is A to B? And I hope you're seeing that on this guy, you need to subtract. See, with addition, whenever you start with small pieces and conclude a big piece, you're adding. Let me say that again. When you start with small pieces and conclude a big piece, you're adding. With subtraction, you begin with a big piece like AC, the whole length. And then you have a small piece, but you conclude a small piece. That is subtraction. So the correct thing here is if AC is 4 and BC is, if AC is 14 and BC is 4, find AB. AB works out to be 10. Again, small and small to big is addition. Big and small to small is subtraction. So key conclusions. Postulates, also known as axioms, are accepted as true even though we cannot prove them. A little sloppy grammar there. I should have a parenthesis after axioms. Addition postulate, when equals are added to equals, you get equals. Subtraction postulate, when equals are subtracted from equals, you get equals. Specificity is critical. AB means the distance from A to B. This is a number. Segment AB means the line segment connecting A and B. This is a shape. Okay, we'll get on to basic shapes next.